when we're here, we have, again, where the ray HL bisects angle GHJ, and we want to find the measures of GHL and angle GHJ. So our first part here, we want to do the total angle, which is the measure of angle. And write it in blue. So the measure of my total angle, what's my total angle? Let's start over here. So what's my big angle, somebody in this column? What is it? What's my big angle? GHJ. Exactly right, GHJ equals the sum of my two smaller angles. So what are my two smaller angles? The middle column. Jaquan? Yep, GHL plus the measure of angle LHJ. Nice job. Our next step is to show what? Yep, Natalie? That's okay. So the second step, right, is to show what happens when they're bisected. Raj? Yep, we're going to show that they're equal so that we know, because we know they're congruent. So the measure of GHL equals the measure of angle LHJ. Nice job. Now you guys get to pick, which one do you prefer? GHL or LHJ? GHL works for me. So we have the measure of angle GHJ equals the measure of GHL plus the measure of angle GHL. How many GHLs do we have? We have 2. So you can rewrite that as 2 times the measure of angle GHL. Okay. In this case, we have one measurement. What measurement do we have? We know the measure of angle LHJ is 64. Based on this line here, we know that GHL and LHJ are the same. So I can say that the measure of angle GHL is also going to be 64. So when I go down here, I can substitute that in. The measure of angle GHJ equals 2 times the measure of 64. What is 2 times 64? 128. Nice job. So we end up with that being 128 degrees. If we're looking at that angle, GHJ, is it acute, right, obtuse, or straight? It is obtuse. How did you know it? Yep. Bigger than 90, less than 180. Nice job, guys. So for the next group, we talk about how QS, ray QS, bisects angle PQR. We want to find the value of X. So this one is the type I told you didn't have to show as much work with. So we want to just say that the two angles that are smaller are what? Are equal, exactly right. So the measure of angle PQS equals the measure of angle SQR. We know the measure of PQS. What is it? Kevin, were you raising your hand? Okay. 32 degrees. I'll write that a little nicer. 32 degrees. And we know the measure of angle SQR is? Nice job. 5x minus 3. We want to combine our like terms. What do? Add 3. Add 3. We end up with 35 equals 5x. How do I get x by itself? Divide by 5. So we get x equals? Nice job. Okay. For us to do the next part, that blue writing I had, I have to erase. Does anybody still need the blue writing? Okay. So I'm going to get rid of that so we can use it for our next portion. Okay. I'll change my color again so we can differentiate. Okay, so again we have angle PQR and it's being bisected by QS, the ray QS. Our first statement is to show that those two are equal. So the measure of angle PQS equals the measure of angle SQR. We know the value of PQS. What's the measure of that angle? 9y. What's the measure of angle SQR? Exactly right, guys. How do we get our like terms together? Yep, subtract y, 8y. When we do that, we get y equals 10. Okay. Today, we are going to be talking about complementary and supplementary angles. So your objective is to be able to find the measure of a complementary and supplementary angles. So your first vocabulary word is complementary angles. Two angles who have measure of a sum of 90 degrees. So you're going to add the two angles together, and they're going to have a measure of 90 degrees. And then each angle is the complement of the other one. So to help my students last year remember this, I talked about how, in general, we like to give compliments to one another, right? People feel good when you give compliments. So when you give compliments, or you're receiving them, either way, you're doing a right thing, right? You're doing something good. You're doing what's right. So giving compliments is what's right. Right means 90 degrees. So complementary, 90 degrees. We have supplementary, two angles whose measures have a sum of 180 degrees. What figure is 180 degrees? What type of angle is that? Yep, it's a straight line, straight angle. And so each angle is the supplement of the other. And then we have adjacent angles, two angles that share a common vertex and one side but have no other common interior points. I'll draw an example with that so you can see it when you go to mark this part down. I'll put it over here, I guess. So I'm going to label these angle 1 and angle 2. So angle 1 and angle 2 are adjacent angles. They share a common vertex, and they share one ray. So we can see that with A here. We'll put B here, C, and D. And then your last thing is a theorem, a statement that follows from other true statements. So, Congruent Comptements Theorem, if two angles are complementary to the same angle, then they are congruent. So if measure of angle 1 plus the measure of angle 2 equals 90 degrees, and the measure of angle 2 plus the measure of angle 3 is 90 degrees, then we know that the measure of angle 1 and the measure of angle 2 have to be congruent. So if you did an example of this, and you knew the measure of angle 1 was 60 degrees, and the measure of angle 2 was 30 degrees, and here we know that this is 30 degrees, how much would measure of angle 3 have to be for it to be complementary? Do you need a second? I'll pause. So if you had the measure of angle 1 being 60 degrees and the measure of angle 2 being 30 degrees, you see if you add them up, you get 90. Well, if we had the measure of angle 2 being 30 degrees plus the measure of angle 3, and it's going to equal 90, how much does the measure of angle 3 have to be? It has to be 60, right? So you see that both measure of angle 1 and the measure of angle 3 are the same. And that's what this theorem is showing. So if you have two things that are going to be complementary to the same angle, then they are going to have to be congruent. And the same thing is occurring in the supplementary theorem. So if two angles are supplementary to the same angle, then they are also going to be congruent. So we want to determine whether these angles are complementary or supplementary or neither. So our first two angles, we want to add them together. You have 45 plus 55. When you add those together, what do you get? I heard somebody say it, what? Well, more than that. 100, yep. So 100 degrees. Is 100 degrees equal to 90 or 180? No, right? It's not 90 degrees. It's not 180 degrees. So it's not going to be complementary. It's not going to be supplementary. We're going to say it's going to be neither. Okay, for B, the one you drew in, we have one angle that is 148 degrees. Nope, that's 43. Sorry, 143 degrees. And we have 37 degrees. We're going to add those together. When you add those together, what do you get? I had to give it to you in the problem. So I had to have you guys. Yeah. Oh, sorry. I'll make it a little clearer. There we go. So when you add 143 plus 37, yep, 180. So you see this picture is not drawn accurately, but is complementary, supplementary, or neither? Yep, it's supplementary because we know that it is equal to 180. Okay, and then our last one down here, you have 42 plus 48. When you add those together, you get 90. And then is that complementary, supplementary, or neither? Complementary. Okay. So you had a neither, you had a supplementary, and then you had a complementary. Our first part here is we want to determine whether the numbered angles are adjacent or non-adjacent. So what was our definition to be adjacent angles? Gave it to you on the last page. Yusef?
So angles that share a common vertex.
And?
One side, but no common interior.
Exactly right. So if we look at 3 and 4, do they share a common vertex? Yep. Do they share a common side? Yep. Is there any points that are going to be in both of them? Nope. So we can say that those are adjacent angles. So adjacent angles. They have a vertex, a common side, no and common interior point. Our next one up. Okay, do they share the same vertex? Yeah, do they share the same side? No. They have one side here, Neither of them are comprised of the same side for it to make it up. So are they going to be adjacent? Nope, so we say they're non-adjacent. Or not adjacent. Okay, over here. All right, don't share a common side. Just in case when you look back. Over here we have angles 1 and 2. Do they share the same vertex? Nope. So we know that they are not going to be adjacent either. Don't share same vertex. Or common side. Okay. So the angle F is the complement to angle G. And the measure of angle F is 23 degrees. What is the measure of angle G? If we know that they are complements, how much do they have to equal? Exactly right. Measure of angle F plus the measure of angle G is going to equal 90 degrees. We know that the measure of angle F is 23 degrees. So if we were going to solve for the measure of angle G, what do I have to do now? Exactly right. Subtract 23. When I subtract 23, what do I get? Yep, exactly right. 67 degrees. So this part, we took the two that we knew. We set them equal to 90. You subtracted the one that you knew. And then we know what the other one has to be, because if it's complementary, it has to equal 90 degrees. Giving complements is what's right. Over here, we now have S is supplementary to the angle T. So supplementary means they add up to? Exactly right. Measure of angle T equals 180. We know that the measure of angle S is 95 degrees. Plus the measure of angle T, that's a really bad M here, equals 180. How do I solve for that? Subtract. When you subtract, what do you get? 85. Thank you very much, ma'am. The measure, angle 1 and angle 3 are complementary. So I'm going to write that out. Measure of angle 1 plus the measure of angle 3 equals what? 90 degrees. Okay, and the measure of angle 3, or angle 3 and angle 5 are complementary. So I'm going to write that out as well. Measure of angle 3 plus the measure of angle 5 equals complementary, you told me, is 90 degrees. Okay. Name a pair of congruent angles and explain. So what do we know? Which ones have to be congruent? I gave you this in a theorem a few minutes ago. So we want to know, name a pair of congruent angles based on this information. Name a pair of congruent angles. You have part of it, yeah. I hear you. 1 and? Not 1 and 5. So the measure of angle 1 is going to be congruent to the measure of angle, well, it's going to be equal. I'll say it that way. It's going to be equal to the measure of angle 5. And we knew this based on our theorem. I'll flip back to make sure I read it to you correctly. But we have, if two angles are complementary to the same angle, then they are congruent. So that was the congruence complements theorem. And so therefore we can say that the angle 1 is congruent to angle 5. So based on that theorem, because they are both complementary to the same angle, so we don't know that measure, but let's say it was 20. If this was 20, this one would have to be 70, right? If this was 20, how much would this one have to be? 70 again. So they had to be equal measure. So therefore we can say they're congruent. Okay? So our first step here is if we know that they're supplementary and we're solving for x, so we're going to take our two angles that we know are supplementary to each other and set them equal to, how much is supplementary? 180. So we have the measure of angle ABD plus the measure of angle DBC equals 180. We know the measure of angle ABD. How much is it? 5x plus 20. How much is DBC? X plus 40. I heard somebody whispering. Equals 180. We're going to combine those like terms. Like terms are going to be the constant terms and the variable terms. So the ones that have the variables, how many x's do we have? 6x. 20 plus 40. 60 equals 180. We got to get our like terms together one more time. How do I get 60 to the other side? Subtract it. I'm going to write all of this next to it right here. Can you see that okay if I do it? What is 6x? So if we subtracted 60 from both sides, what do we get? 180 minus 60 gives me 120. We're going to divide by 6. X equals 60. Oh, nope. Check my math. X equals 20. Sorry about that. X equals 20. Okay, our next one, just so we can have time to finish it. We see that these angles are complementary. So if they're complementary, how much do they add up to? Exactly right. So the measure of angle ABD plus the measure of angle DBC equals 90 degrees. We know the measure of angle ABD. How much is it? Exactly right. How much is DBC? Exactly right. Nice job, guys. Equals 90. Combine like terms. 2x plus 3x's plus 10 equals 90. Got to get those like terms together. I got to subtract that 10. I'm going to write it here so you can see it a little better. We end up with 5x equals 90 minus 10. 80. We're going to divide each side by. Okay, how many times does 5 go into 80? 16. Yep. Okay, so this lesson was about complementary and supplementary. You guys already know complementary adds up to 90. Supplementary adds up to 180. What does it mean to be adjacent? Same vertex, same side, no common interior points, so they lay next to each other. Okay, so you guys should be able to complete your homework this weekend. I'd like you to at least try it. Come in with questions if you have them. Your review will start on Tuesday or Monday. The quiz will be on Tuesday. Oh, fist to 5. We'll do thumbs. Thumbs up. You felt okay. Sideways, still a little bit. Still need help. Lisa. Okay. Delaney, hun. Okay. Okay. Hi. I see yours. Okay. Look here. Okay. Okay. So first group, go grab your phones. Oh yeah, you guys are my first group most days. You both first groups. Let's make the middle group wait. Sorry, middle group.
No, you're not.
Probably not. Not like legit sorry. Not sorry enough that I won't do it again. Okay, Kevin, you gotta take the hat off, dude. Middle group. I hope that you all enjoy your weekend full of sleeping, which seems to be the most fun thing any of us are doing. We have 1 more minute. Did everybody grab their phones? There's one still lingering. Okay, I just want to make sure that no one's taking anybody else's phones. Bring my other ones up there, hon.